Hello, everyone. So I wanted to create a quick video describing what you need to do for the graphical interpretation lab report. So again, this lab is fairly similar for all three of my physics labs, or physics 212, 206, and 207. Actually, in physics 212, this is going to be lab 4. In physics 206 and 207, this is lab 5. And the only difference is the number of questions that you have to do. Physics 206 will be just doing the first 6 questions. Physics 207 is responsible for the first 9 questions. And you'll see this on your handout, right? It'll be a separate handout. And then Physics 212 is responsible for all 12 questions on this handout. Okay, but it's just easier to create one video and go through all this. But after the first 6, after I discuss the first 6 questions, and you can, if you're in Physics 206, you can stop and so on. Now, for the lab write-up for this particular lab report, what I would do is you could just type in the correct answers, like neatly type them in. And if you need to do any drawing, you could do the drawing right on the handout itself. And then I would just add a cover page, right? As long as it's done neatly, it's fine to use this particular handout, fill in all these answers here. Add a cover page, and then the usual one person from the group will submit it to me as a hard copy the following week. Okay, so hopefully you watched the video on the practice graphical interpretation examples. That's very important because in that video, I go over how to answer these types of questions. So now for your lab report, the first question, I give you a position versus time graph, right? Remember, this is a particle moving in one dimension. You can think of it as moving along the x-axis, either in the positive x-axis direction or negative x-axis direction. Okay, so it's moving in one dimension, back or forth, or it could be at rest. So given this position versus time graph, I want you to answer these questions based on that particular graph. All right, so that's the first question. Second question is, given this position versus time graph, I want you to draw the corresponding velocity versus time graph. Okay, and again, you could do the drawing on a computer by drawing in lines here if you want, or you could just do it neatly by hand. It's fine. As long as it's done neatly for your lab report, that's fine. Now, remember, how do you find the velocity if you know the position versus time? Remember, the slope of the position versus time graph is equal to the velocity. So we have these straight line segments, you're going to have a constant slope. So for instance, in this case, right, over the first 2 seconds, my rise is 4 meters. My run is 2 seconds. So rise divided by run, 4 divided by 2 is 2. So that means the slope is 2 meters per second, which is my velocity. And in fact, it's constant throughout this entire time interval. So really in this graph right here, from 0 to 2 seconds, you would just have a constant velocity of 2. So it would be a straight horizontal line like this. And then it's going to jump, right? Remember, these aren't realistic. You kind of have to ignore the kinks here, but it jumps from a positive velocity to a negative velocity and so on. So you want to draw the corresponding velocity versus time graph. Okay, then I give you, for the third question, I give you a more complex position versus time graph. Here, the first part, it's actually curved. It's actually a parabola from 0 to 4 seconds. Okay. And the rest of it is straight line segments. So again, I want you to, based on that graph, answer these questions about that position versus time graph. Then given that graph, draw the corresponding velocity versus time graph. Now, let me help you out at the beginning here. So remember, the slope of the position versus time graph is equal to the velocity, right? The slope at any point, if I draw a tangent line to the graph at that point, say right here, that would be the instantaneous velocity at that time. If I draw it here, that'd be the instantaneous velocity at that time. If I draw at the beginning, it's pretty much flat. So that'd be like 0, velocity would be 0. So in this case, from 0 to 4 seconds, this object is accelerating, right? Its velocity is increasing, it's changing. It's going from a zero slope to a steeper slope, steeper, 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 until it gets to 4 seconds. And if you take a ruler and approximate this, it turns out it's about 8. It's about 8 meters per second is that slope there, right at 4 seconds. So how do you draw that part? Well, the velocity at 0 seconds is 0. So you have a dot here. We know it's increasing. And we know at 4 seconds, the velocity is 8 because the slope is 8. So at 4 seconds, it's 8. So how does it increase? Well, your best guess would be like it linearly increases. Okay, and that turns out to be correct in this case. Since this is curved and we know mathematically it's a quadratic function, it turns out the velocity is going to be a linear function. And then everything else, there's going to be constant velocities, right? So those are just going to be horizontal lines. But the first part is a little tricky. Okay, then for question 5, I give you a velocity versus time graph, right? So remember, if I ask a question about velocity, you can read it directly off the graph. If I ask you a question about the acceleration, that is the slope of the velocity versus time graph. And if I ask you a question about displacement, it's the area underneath the graph. So like, for instance, if you want to know the displacement from 0 to 3 seconds, you'd have to break this up into like a triangle and a rectangle, calculate that area, and that would be the displacement. In fact, since it's positive, it'd be a positive displacement over the first 3 seconds. Right, so the area underneath the velocity versus time graph is the displacement. So answer the questions about that velocity graph, and then draw the corresponding acceleration versus time graph, which is really just the slopes, right, of velocity versus time graph. Okay, so if you're in physics 206, that's all you have to do, just do question 6. If you're in physics 207, there's a few more questions. So here, question 7 is slightly more complicated velocity versus time graph because in this case, right, the velocity is positive from 0 to 1 seconds. In fact, the object is slowing down right at 1 second. It looks like it's at rest, right? It's 0, or at least instantaneously at rest. And then what happens after from like 1 second all the way to 7, the velocity is negative, right? Because it's negative values here. So it's moving backwards here, moving forward here, backwards here, and then forward again. So again, given this graph, this velocity versus time graph, I want you to answer all the questions about that particular graph. And be careful when I ask you about displacement, right? If the velocity is positive, then when you calculate the area, so it'll be like the area of this triangle, that's going to be a positive value. But when the velocity is negative, when I calculate the area of this triangle or this rectangle or the square here, and then this triangle, these are all going to be negative. And then the velocity, the display, so positive displacement, right? Because velocity is positive, negative displacement here, and then this will be positive again. In this case, you have to be a little careful. Probably what you want to do is break this up into a triangle like this, right? That triangle, then maybe this one, and then this rectangle here. And that's all going to be positive displacement, right? Because the velocity is positive. So you're going to answer questions about that particular graph. Okay, and then question 8, so I give you 3 graphs. One is acceleration versus time, one is velocity versus time, one is position versus time. And they don't correspond to the same motion. They're just like 3 independent graphs of acceleration, velocity, and position. Okay, so they don't correspond to the same motion. And then I have parts of the graph labeled, so A, B, C, D, E, F, G, H, I, J, K, L, M, right, labeled. So I want you to choose all the letters where the acceleration is 0. So in other words, if you have an acceleration versus time graph, what does it mean for the acceleration to be 0, right? Find the letter or letters that represent that. If you have a velocity versus time graph, what does it mean for the acceleration to be 0? And then finally, if you have a position versus time graph, what does it mean for the acceleration to be 0? So you're just indicating the letters where the acceleration is 0. And I'll give you a hint. For all 3 of these graphs, you're going to come up with 4 letters here. Okay, and then the last question that physics 207 needs to do is this one, question 9. So if we have a more complicated graph, and here I have like it's curved here, then it's straight. So this isn't too bad. But if you have a more complicated graph, one way of at least estimating the displacement is by fitting rectangles to your graph. So I started the process here for you. So basically, in this case, I stopped at about 1.5 because see how I'm including this piece, which really shouldn't be included, because if I want to find the displacement, say from 0 to 1, I want the area underneath the graph, right, or the curved part. But I'm going to estimate it by finding the area of this little rectangle here. So I'm kind of missing this piece or including this piece by accident and then missing this little piece, but they kind of balance out, right, if I make it right at 1.5. Same thing here. I'm including this piece, but missing this piece. So I thought maybe like 3.5 would be good. Maybe from 2 to 3 seconds, maybe you'd go up to like, maybe 7, right? Something like that. Actually, where it's linear here, you definitely want to go right in between. Like if I go all the way up to 10, that won't work because then I'm including this huge piece right here. But if I go to 9, so over at 9, see how I'm missing this piece, but including this piece, and they exactly balance out, right? So the area underneath this part is going to be exactly equal to the area of this rectangle if I go to 9. So then you probably want to split this up, go to like 7, then 5, then 3, and then 1. And then here maybe -2. Remember negative, so these are going to be subtracting these displacements. Then all the way down to -4, -4, and then maybe -2. So you're breaking this up into rectangles, calculating the area of the rectangles, which is easy to calculate, right? Just length times width. And all the widths are here are 1, right? 1 second. And then add them all up. Remember, this is going to be negative, but this will all be positive because the velocity is positive. And then find the net displacement, right? So you're estimating the total net displacement by calculating the area of these rectangles. Okay, and then once you've done that, Physics 207 will be done with this particular lab. Now, Physics 212, I added a few more questions here. So here's another velocity versus time graph. This is a little more complicated, okay, because it's curved quite a bit. So what I want you to do is, given this graph, answer these questions. Now, remember, if I ask you a question about velocity, like the first 3 questions here, you can just read it directly off of the graph. If I ask you a question about acceleration, what do you need to do? You need to calculate the slope of the graph, right? So for instance, if I ask you about the acceleration at 9 seconds, if you go to 9 seconds, what I would do is maybe take a ruler and draw a tangent line that just touches the graph right at 9 seconds. So something like that. So you draw a line in there, and then you're going to estimate the slope by computing rise over run. Okay, it turns out it should be around 4 because it kind of goes right like that. So it should be around, sorry, it should be -4, right? Because it's a negative slope here. So it should be like -4 meters per second squared. Then you're going to estimate the acceleration at 11 seconds. Actually, that's easy, right? What would that slope be of the tangent line? And then at 13.5, which is right here. And this is linear, so you can just calculate that slope, and that will be the acceleration at that point right there at 13.5 seconds. Okay, then I want you to estimate the displacement over the first 4 seconds. So from 0 to 4. Well, the velocity is negative. It's curved, so you can't easily draw in, geometric figures. But what you could do is estimate this by fitting rectangles again, right? And kind of like, if you're missing a piece, like kind of balance it so it's like cutting it in half. So you're including a piece and missing a piece, and they kind of balance out, right? So you're getting a pretty good estimate. Like maybe from 1 to 2, I would go to like -3.5. That would probably be good. And then 2 to 3, same thing, -3.5. Because then you're missing this little piece, but including this little piece, and they kind of balance out. Okay, so from 0 to 4, that's going to be some negative value, right? Because the velocity is negative. Then I want you to calculate the displacement, or at least estimate it over the entire 14 seconds. So again, then you got to keep going by fitting This part, by the way, from 4 to 5 is linear, so you probably want to go halfway. You're going to keep estimating by fitting rectangles in here. Okay, next, given that same graph, given this velocity versus time graph, I want you to draw the corresponding acceleration versus time graph. Again, it's a little tricky. So how do we find acceleration? We have to find the slopes, right? But this is curved in most places. So you need to estimate it. So here, I'll get you started. So at the beginning here at 0 seconds, if you were to take a ruler and draw a tangent line there, it turns out that that's going to be -4 meters per second squared. And then it's what's going to happen. That slope is going to increase, right? It'll be like, say, -3, -2, -1. And right at 2 seconds, it'll be 0, right? Acceleration 0. So it's going from -4 at 0 seconds, and at 2 seconds it's 0. So it's, and then we know it's increasing. Your best guess is linear, and it turns out it's truly linear. So it's going to look like this, up to 0 at 2 seconds. So it starts at -4 at 0 seconds, and it goes all the way up to 0 at 2 seconds. Then from 2 to 4, right? It's 0 at 2, then it's increasing. You want to estimate the acceleration right at 4 seconds. If you find that slope, it turns out that slope is +4. So this is going to keep going to, I was at 2, right? To 4 seconds, it would be +4. So it's just going to be linear all the way to +4. Then from 4 to 5, it's just a line. So find the slope of that line, and it's going to be that constant value, right? It'd be a horizontal line. Then it's going to decrease, right, to 0. Then it keeps decreasing to like negative. At 9, it's like -4. Then it increases again to 0, increases to +4, and then stays at +4 for the last second. Okay, so that should give you some idea of how to draw the acceleration graph. And then the last question, if you're in physics 212, is this one, question 12. So I give you this scenario. It says a car is traveling on a straight road. Think of it as traveling along the x-axis in the positive direction. It starts at rest at a position of 0 meters. It accelerates for 10 seconds at a constant rate until a velocity of 30 meters per second is reached. It then travels with 0 acceleration for 30 seconds. Right? Remember, 0 acceleration means constant speed, right? Constant velocity. Finally, it decelerates for 10 seconds at a constant rate until it stops. Please sketch the correct position versus time. So given that information, sketch the position versus time, the velocity versus time, and the acceleration versus time graph. And my hint is it's easiest to start with the velocity versus time. Okay, so given that information, you should be able to sketch the correct velocity versus time graph. And then if you look at the slopes of the velocity versus time, that's going to give you the acceleration versus time. And if you look at the displacement, the area underneath the graph, that'll give you the position versus time graph. So start with velocity versus time graph, right? And I want you guys to think a little bit about this. Okay, great. So that should help you guys out with this graphical interpretation lab. Thanks.